Hey, why my Hachime looking so sad, bruh? Like, you think life is sweet?
Man, you past that, you're a fraud anyways. Hi. Today, we're gonna be moving further into derivatives and exploring the role known as implicit differentiation. Compared to explicit differentiation, where one variable is in terms of another, implicit differentiation is where we're gonna be deriving multiple types of variables, and you'll see what I mean. When we have a function looking like this, a polynomial filled with x's and y's, what do we do here? Well, to start, let's start deriving each one. We know how to derive x, but how do you derive y? Well, whenever you derive y, you always include a dy dx. And whenever you're deriving x, it's fine to not include that stuff because it's like saying you're deriving x over x. It just pretty much cancels out. Next, with all these factors in mind, you're going to want to gather all your terms with dy dx on one side. And once you do, you want to factor out that dy dx with all your terms, and then you're just going to want to isolate it. So within here, you're going to want to divide your function to get your dy dx isolated, as we only want that. And then from here, we simply get our derivative. Now, how about we do second derivative, which is just the derivative of a derivative? Well, within this new function, that's exactly what we're going to find. To firstly start, we're going to first find out what dy dx is equal to, and it's going to be fairly easy, as it's just simply what we did before. So, once we do all the steps, we get our dy dx, and it's going to be equal to negative x over y. So, how do we get that second derivative again? Well, we're just going to derive what's there. So, when we apply the quotient rule here, we get this weird function, and we see that we have a dy dx. How do we solve that? Well, to start, we're just going to plug in what our dy dx is equal to, which is just the negative x over y. And now our function looks like this. But to fix it, we're going to have to multiply both the numerator and the denominator by y to fix it all around, so it's not irrational. And once you do that, we're done. We get our second derivative to look like this.